Rosemary, physicists understand there's only an electromagnetism force. Yet, in your clip, you state that there is magnetism as a primary force. Could you elaborate on this?
Right. Now, we know that magnetism, you can get two magnets, and the one magnet will definitely attract another magnet. You can get paramagnetic material, and it will respond to a magnetic field. You can get ferromagnetic material, and it will actively respond to a magnetic force. So, in effect, you can get two magnets that change in time, that are able to change in time, that do not induce an electric field. And the difference between what we're proposing and what our standard model suggests is that there is only the electromagnetic force, and we are showing that the magnetic force has got no electric field associated with it unless it is first induced by an electric field.
So you're basically stating that as the magnet moves, there is no electricity.
There is no evident electrical field. They have actually tried to find an electric field in the process of two magnets interacting, and it has not been found. I know of one paper that has been written on this. I know that the results were inconclusive. I can't remember the parameters of that particular test, but I do know that they have never yet been able to prove that a magnetic force induces an electric field. They have never found an electric force without a magnetic field. Therefore, we're suggesting that the magnetic field may be a primary force.
Your method of analysis is not typical to what most people do their research on. Why is this?
In the scientific world, what I've done is, it's a new field, it's very abstract, and I've tried to explain it using conceptual physics. And the whole field of conceptual physics was advanced by a guy called Dyson in a textbook called Conceptual Physics. Brilliant, brilliant treatise, which is widely used by a lot of different academies. But the point about it is that he relies on pure concept and the logic behind the concept to develop both an understanding and the science itself.
The standard model, how effective is it? We all use it today in the scientific world, but is it based on what we've found so far? Are there any paradoxical problems?
Yes, there are a lot. A very profound contradiction in terms of the standard model is Einstein's famous equation, which is E equals mc squared. And everybody knows that in terms of this, energy times the speed of light, energy equals the speed of light times the mass. And if this were true, the photon has zero mass. We know that it has no measurable mass whatsoever. However, if you take the photon times the speed of light, you would have 0 times 300,000 kilometers per second, and the result would be 0.
Absolutely.
So that is one example. There are other questions related to the mass, to the wave-particle duality, the Casimir effect, which nobody's been able to explain. There are many questions still outstanding in physics that have not been touched on, and very often not even mentioned, including the one on magnetism being a primary independent force.
So basically, with the E equals mc squared, you're saying that light has no energy because the photon being 0, the speed being 300 equals 0, therefore there's no energy, but we do know that light has got energy.
Exactly. The point is that if we are going to attribute any kind of energy quotient to a photon, then it needs to be 0. In effect, in terms of the standard model, it is 0. And self-evidently, it's got a lot of energy.
In your video, you state that the particle takes, in 1 second, it covers 300 kilometers. But you're also saying that a big particle will travel slower than a smaller particle. But if they're both covering the same distance at the same time, therefore they're both traveling at the same speed. So what are you talking about when you talk about the velocity versus the actual speed and distance?
Right. Okay. There is a distinction. The distinction is this. We're claiming that if a particle is considerably smaller, for instance, the analogy is, it's best explained this way. You take a man who will cross a room in a certain fixed period of time, and he's racing his son, and his son also coincidentally crosses the room in the same period of time. Now, the rate at which the son moves, because his relative size is less than his father's, therefore the amount of energy that the child would have had to expend is greater than the amount of energy that the father would have to expend, albeit that they achieve the same post, the same goalpost. Now, in terms of velocity, the distinction I am making is that if you attribute volume, I'm not talking mass, just volume, size, to a photon, that one, for instance, let's say that the red photon is considerably bigger than your ultraviolet photon. Now, in terms of that, the point is that the ultraviolet, if it does in fact occupy less space, less volume, the time it will take to reach, if it reaches the same goalpost as the big, is going to be identical, but it would, in terms or related to its size, it would have had to travel at a fast velocity. Now, if you take it, velocity is, as we understand it, that light travels at 300,000 kilometers per second, that's fine. But actually, it simply covers the distance. The rate at which it travels is relative to its size. Therefore, it may, if it is smaller than one particle being smaller than another, it may indeed have to travel at a fast rate to reach that same distance. Which means here's another one of those very basic understandings or paradigms within the standard model, where the assumption is made that it travels at the same speed. And what our model actually does is question that.
You seem to have resolved the wave-particle duality.
Yes. However, within certain very real constraints, very real limitations, because we do not know that we've got the full picture. We've used symmetry to explain the most of it. We've shown a logical sequence or a logical flow of that symmetry, but the full picture needs to be elucidated, and for that we need experts, which are our fractal geometrists and our string theorists.
On this entire video and everything that we've seen so far, what exactly do you see electricity as?
Well, electricity I see as the transfer of these dipoles through a circuit, but it comes from voltage, and I see voltage as being an open string. In effect, the binding fields that we've referenced are broken by the inrush of a magnetic field that has only got one direction, so it's got one charge. So it repels that part of the charge that it is like, and that repulsion takes it outside the structure of the material, outside the copper, outside the resistor. It is forced outside, but being forced outside, it still assembles as a field. But it's now, instead of being a closed field, which is what the string needs for perfect symmetry, it stays open. And it is waiting for an opportunity to experience a closed field again that it can orbit. And in orbiting, it is able to readjust that charge imbalance. So in effect, your voltage is strings, open-ended strings, compiling or comprising these little dipoles. And when the circuit is closed, what the dipole does is it then, at the speed of light, moves through the circuit and closes those strings. And once it's closed those strings, they can then actively redistribute their charge in order to achieve that balance. So the immutable principle is always that the dipoles move to a condition of best balance. That is the immutable imperative. That is the one thing that they all respond to.
Are they trying to get that symmetry perfect and balanced?
They are looking for their own symmetries.
And basically you're saying it's just these magnetic dipoles that are flowing through the circuit.
So literally your flow of electricity is the redistribution of these little dipoles from one point to another in order to close that circle. And when they do that, they are then able to redistribute that charge as they need it. And in your electrolytic mix of a battery, for instance, it will then be in a position to redistribute the charge, so redistribute the binding, that they can change that the electrolyte to something that is actually more balanced.
And as these dipoles are moving through the circuit, they are obviously cutting the windings and the resistors and the things. Could you
so as they are moving through the circuit, they don't interact with the atom. They're actually interacting with the binding fields, the fields that hold the atoms, and that part of the field that they leave behind is that part of the field that actually then becomes flux. It goes out of its bound, it loses its bound condition, it loses its orderly condition in the field, and it that remains in the structure of that material gets hot and big and slow. It becomes flux. And the immediate result is that you can actually see it in the expansion of the material itself. So we're proposing that the heat that is experienced in any material is actually the result of these dipoles coming out of a orderly cold formation and coming into our own dimensions of space and time as hot and slow and measurable structures.
Firstly, you've just shown that you've got the dipoles, 6, and by adding another 6 forms a perfect circle.
Yeah.
If you take out the string on the outside, you add in those 6 plus another 6, you've got another perfect circle. And each time this grows, by adding only 6, it remains a perfect circle.
Yeah.
You're telling me that no mathematician or scientist has ever come across this pattern before?
To the best of my knowledge, nobody has ever seen this before. There is a symmetry. It was actually developed by Rian Tron. And what it involved is we were looking for an association where you could complete a circle, or could get into a two-dimensional structure, but sustaining a much-needed symmetry, because symmetry is everything in particle physics.
Sure.
So, we discussed this at length on the forums, and certainly at some stage Jonathan Martin came up with a solution, but he then forgot what that solution was. And it was only Rian who found that exact, precise number, which, curiously, as you said, is based on, you start with your diameter, then you put 6 identical diameters around that and they slot in perfectly. Then you add another 6 to the outside diameter and you've got 18 slots in perfectly. Then you put in the 12 and then 18 and so it goes on, 24 and so it goes on. So the point being that that symmetry, it has not, to the best of my knowledge, ever been seen. I've actually taken the trouble to phone the maths department both at Stellenbosch and at UCT, and nobody has ever heard of it. They couldn't even understand what it was I was saying. So it is definitely Rian Tron's discovery.